Log on, tune in, find out. Another good idea from Cambridge.
So today we welcome Professor Richard Bell, who's from Nottingham University Faculty of Theology. He actually has a doctorate in both theoretical physics from UC London and also in theology from Tübingen. He's currently working on a theology of mind and therefore is extremely well qualified to address us today on the topic Mind and Matter of the World as Representation in Quantum Theory. So thanks very much, Richard.
So hi everybody, I'll just try out, is this working? Can everybody hear me?
Yes.
And I've just put this in my pocket, is that alright?
Yes.
Great.
It's not going to do any damage? Yeah. Okay, I'd like to thank Dennis first of all for inviting me to speak to you, and also for all the administrative staff like Holly and Zoe. So thank you very much. It's great to have this support and everything's so well organised. And I'm very, very pleased to be addressing this esteemed assembly, people I imagine from many, many different disciplines. Can I just ask, first of all, how many of you have a background in quantum mechanics? Okay, right, okay then. Just so I can, I think you'll follow most of this. Anyway, those who don't have quantum mechanics. So the material I'm presenting today is part of a larger project, which I've called the Theology of Mind. And it's a project which grew out of earlier research I did on the exorcisms of Jesus. Now, so far on this Theology of Mind, I published some work on mind in Paul. And if you look at the handout, there's an extensive bibliography and one or two articles I've written on the theology of Paul and the question of mind. But for today, for the first time, I'm addressing mind and quantum theory. So this is fresh research, so I'm open to correction and rebuke in the question and answer session. Okay, so I'm not saying this is perfect, some of it may well be wrong. But anyway, I'll give you what I've done so far. Now, one of the key challenges in this sort of interdisciplinary work is which philosophical framework to adopt. And in my work on the exorcisms of Jesus, I used two philosophers mainly, Immanuel Kant and his disciple Arthur Schopenhauer. Now, any philosophical system is going to have certain drawbacks, and there are certainly problems with Kant and Schopenhauer. However, I discovered that a critical use of the transcendental idealism could open up many interesting avenues, not only in relation to natural science, but also in relation to the arts. Indeed, they are able to bring together arts and sciences, I think, better than any other system I know of. And so to the issue of today, mind and matter, the world as representation in quantum theory. The human mind is mysterious, and even those researchers who take a rather materialistic view of the human person are confronted by the mystery of human consciousness. Kant and Schopenhauer, in their different ways, have, I think, captured something of this mystery. And part of my argument today is that the mystery of the human mind is correlated to the mystery of the physical universe. I'm going to start by considering what Kant and Schopenhauer say about mind and matter, and then in a second section, ask how these issues appear in the light of quantum theory. So first, the transcendental idealism of Kant and Schopenhauer. The philosophical system which they developed is often called transcendental idealism. And the word transcendental has often been confused with transcendence. But these terms point in opposite directions. The etymology of both words is to climb over, trans over, scandro, climb. And both mean exceeding experience. But whereas a transcendent object exceeds experience in that it is beyond experience and remote, a transcendental structure exceeds experience because it is a precondition for experience. So one of the central questions Kant and Schopenhauer were dealing with is how objects can be given to us as subjects. For Kant, as we shall see, this subject is very much related to the human mind. Such a mind could be conceived as something immaterial, but not immaterial in the sense that Descartes would understand it. So Kant does not have a Cartesian dualism with an immaterial mind interacting with a physical brain and body. We have something much more subtle. The mind or subject is, so to speak, a perspective on the world. The subject is not in the world, the subject is on the boundary of the world. So Wittgenstein, under the influence of Schopenhauer, gave this famous picture in the Tractatus, it's on the handouts, and in the first picture on the left, he's simply saying that the I is not in the field of view. And then I've added my own second diagram to show that the subject is actually a perspective on the world. So you can understand the subject as a perspective on the world. Now, Kant's Copernican revolution was that objects are not simply out there existing independently of the observer. Rather, they are given to us as subjects. And one of the remarkable claims of transcendental idealism is that objects conform to subjects. And this has echoes, of course, in quantum measurement. Now, for Kant and Schopenhauer, there's no dispute about there being a reality out there independent of the subject. But this reality is what they call the noumenal world, or thing in itself, German das Ding an sich. And the philosopher Geoffrey Warnock said that for Kant, you would have to be God to be acquainted with things as they are in themselves. Only such a being can encounter things, quote, in some completely timeless way, without a particular point of view in space or any other kind of spatial limitation, with no particular sensory limitations on the mode of acquaintance, and of course, not thinking in French or English or any particular language, not even in any specific conceptual form at all. End of quote. So if we as finite human beings cannot encounter the thing in itself, what do we encounter? Well, in normal, everyday experience, we encounter what they call the phenomena. And Kant and Schopenhauer sometimes spoke of this as representation, German Vorstellung. So each of us now is forming a representation of this room, and in doing this we are faced with certain human limitations. So we are receptive to only a narrow band of electromagnetic radiation. A dog, if a dog were here, would form a different representation. A bat would form a quite different representation, which is virtually impossible for us to imagine. Arthur Schopenhauer begins his magnum opus, The World as Will and Representation, with these words. And this is on the handout. The world is my representation. This is a truth valid with reference to every living and knowing being, although man alone can bring it into reflective, abstract consciousness. If he really does so, philosophical discernment has dawned on him. It then becomes clear and certain to him that he does not know a sun and an earth, but only an eye that sees a sun, a hand that feels an earth, and that the world around him is there only as representation, Vorstellung. In other words, only in reference to another thing, namely that which represents, das Vorstellende, and this is himself. This is very, very opening of his work, The World as Will and Representation. And if only Kant could write with such clarity, and I'll just say this, if transcendental idealism is new to you, start by reading Schopenhauer rather than Kant. It's very, very interesting. If you look at Wittgenstein's Kantianism, virtually all of it comes via Schopenhauer. Okay. So, that which represents is the subject. The thing represented is the object of the phenomenal world. And so the world can be understood, therefore, as representation, Vorstellung. But more fundamentally, the world can be understood, or rather not understood, as thing in itself. And Schopenhauer just incidentally called this thing in itself the will, and thereby caused considerable confusion. But I'd say this in his defense: had he not used the term will, we wouldn't have the Nietzsche we now know, and we probably wouldn't have the Freud we now know. So I think he's enriched our experience by introducing the term will. Now, this term subject is related to mind in Kant and Schopenhauer. And it may be worth emphasizing that the terms they use for mind can be rather confusing and untidy. And this is particularly so for Kant. You may consider this to be weakness, but in my experience, many of the greatest and profoundest thinkers on anthropology use terms which are messy and sometimes confusing. You find this with Kant, you will also find it with St. Paul, and I suspect such untidiness in the discussion of anthropology suggests not so much lax thinking, but it suggests that these great thinkers are grappling with some of the greatest mysteries of human existence. Kant speaks quite a lot about mind, and in fact it is fundamental to his argument in the Critique of Pure Reason. But it's not always easy to determine his understanding of mind, since there is no sustained discussion of it, and he employs a number of terms which carry different connotations. To simplify matters, I want to focus on just two terms he uses. So Gemüt, which is on the handout, which you can translate as mind, subject, obviously translated as subject. Gemüt appears to be used for mind as an organ of thought, or, quote, a corporeal sense of sensation and self-affection. The term appears at the beginning of what's called the transcendental aesthetic, and that's the major first section of the Critique of Pure Reason. And the commentator, Kent Smith, comments this is on your handout again. He says, mind, that's Gemüt, is a neutral term without metaphysical implications. It is practically equivalent to the term which is substituted for it in the next paragraph, power of representation. So the German there is Vorstellungsfähigkeit. And Kegel writes, Gemüt does not designate a substance, whether material or ideal, but is in the position or place of the Gemütskräfte, that's the Gemüt's powers of sensibility, imagination, understanding, and reason. So the term Gemüt is not used in the sense of mind or soul as in Descartes. Rather, his idea of Gemüt remains close to the meaning the term possessed in medieval philosophy and mysticism, where it referred to the stable dispositions of the soul which conditions the exercise of all its faculties. Now, what about Schopenhauer? Well, Schopenhauer does use the term Gemüt, but only occasionally, and I've found 9 instances in the main body of his work, and it's interesting that he usually uses it in relation to the artist. And I think it's perhaps significant that Schopenhauer prefers the term Gehirn, brain. But it would be a mistake to consider Schopenhauer a materialist for using the term brain rather than Gehirn, rather than Gemüt. And I think if you were to cross-examine him, he would say what we call the brain is a representation of the subject. The brain is part of the phenomenal world. Now, in addition to Gehirn, Schopenhauer uses the term Geist, because many people think of Geist as spirit, but Geist here essentially means mind when Schopenhauer uses the term, and he also uses the term subject. For Schopenhauer, the subject is always correlated to the object in a certain manner. And he writes this is on the handout, in precisely the same manner, with an object determined in any way, the subject also is at once assumed as knowing in just such a way. To this extent, it is immaterial whether I say that objects have such and such special and inherent determinations, or that the subject knows in such and such ways. This idea of the correlation between the subject and the object can be applied to illumine a number of puzzles and mysteries. Now, these are bold claims, so I'm going to take a deep breath here first. It could explain why mathematics is able to disclose the fundamental structures of the physical world, because of the correlation between subject and object. The phenomenal world correlates to the rationality of the human person, and this rationality includes mathematics. And one could go a step further if you believe in God and say that, well, the intelligibility of the world is reflected in the rationality of human beings, which in turn may reflect the rationality of God. So that's the first thing this correlation could explain. Secondly, this correlation may explain why the mind appears to be written in the very fabric of the universe. And this is related, of course, to the so-called anthropic principle and fine-tuning of the universe. So Davis suggests that, quote, life and mind are etched deeply into the fabric of the cosmos. Using a Schopenhauerian framework, we can say that this is no surprise, since the cosmos, the object, is correlated to the mind, the subject. Third illumination. This correlation may explain what happens in the aesthetic experience when our normal interaction with the world seems to be suspended. And Schopenhauer called this representation independent of the principle of sufficient reason. So when you're overtaken by a wonderful opera or artwork or whatever. Fourth, this correlation may explain why only some people are susceptible to religious experiences. So if you take the case of Paul going on the road to Damascus, only Paul encountered the risen Christ. Those with him did not encounter him. So I would say you can explain this by saying that there was a certain subject-object correlation. If you look at 1 Corinthians 15, the very first verses, you get the same idea. Jesus chose to reveal himself to certain people. So only in certain cases is this subject-object correlation. Now, this subject-object correlation also makes sense in quantum theory. And this now brings me to the second section of the talk, the world as representation in quantum theory. Now, Kant and Schopenhauer were living in a world of Newtonian physics and believed this to be the final theory. Further, they believed that Euclidean geometry was the only geometry which was applicable to the world of experience. Clearly, some modification must be made to the philosophical system in an age of quantum theory and relativity, and I highlight just 2 points. The first regards Euclidean geometry. Kant held that three-dimensional Euclidean space was an a priori form of the human faculty of knowledge. Although Euclidean geometry functions for most of our human experience, so for example, angles of a triangle add to 180 degrees, and that works if you're fitting a kitchen or something, so it's a good approximation, but we know now it only to be an approximation. And after the time of Kant, Euclidean geometry was subsequently overtaken by Riemann and then Hilbert space. Does non-Euclidean geometry therefore invalidate Kant's first critique? And I don't think it does. For Kant's arguments in this transcendental aesthetic can be decoupled from Euclidean geometry, and were he writing today, his argument, I think, would take a different form. The other point also is in the critique, he also says he can envisage a non-Euclidean geometry, and that's something for another day. But, so I don't think this issue of Euclidean geometry therefore invalidates Kant. And one of the things that I find rather irritating is that they just write off these great thinkers, saying, oh, well, we know that, Newtonian physics is no longer the final theory. Well, yes. But, I think Kant can be updated to address the 21st century. The second way in which Kant has to be modified is his argument about substance and cause in what's called the transcendental analytic. And that's the second major section of the critique of pure reason. Kant argued that the subject imposes causation on experience. And his argument about causation was related not only to what Hume was saying about causation, but also to the deterministic Newtonian physics. Now, as is well known, quantum theory suggests a world of phenomena where causality can break down. And so quantum mechanics led Heisenberg to conclude this. Kant's arguments for the a priori character of the law of causality no longer apply. But although Heisenberg had doubts about Kant, some of the things he wrote sound remarkably like Kant and Schopenhauer. So he writes this is on the handout. The laws of nature, which we formulate mathematically in quantum theory, deal no longer with the particles themselves, but with our knowledge of the elementary particles. And just read the opening of the world as Willen representation, and you've got really real harmony of thought there. And he writes that with quantum theory, quote, the conception of objective reality evaporated into the mathematics that represents no longer the behaviour of elementary particles, but rather our knowledge of this behaviour. So let me now turn to quantum mechanics and consider how this wonderful thing, the wave function, is related to the world of phenomena, the world of representation. Now, this wonderful thing, the wave function, is a mathematical function which in some sense describes a system, and you can plot it against, 4 dimensions, so 3 dimensions of space and 1 of time. And so on your handout, I've given you a series of equations. I don't want to labour them and go into great detail, but they're there, and I'll just refer to them now quickly. First of all, we have what's called a time-dependent Schrödinger equation. So the wave function is this Greek psi. H is the what's called Hamiltonian operator. You've got a little bit of calculus d by dt. So you've got h psi equals I, h, that's Planck's constant, divided by 2 pi, d by dt of psi. Now, what is this wonderful thing called the wave function? Well, it can describe a very simple system, like a simple electron, or it can describe something like a hydrogen atom, and you can keep going on and on. People say you can even have a wave function for the whole universe. But, normal everyday quantum mechanics, you're simply trying to determine psi for fairly simple systems. And what's interesting is that if you know the wave function at one point in time, it is in principle to know it as a future time. So if you take this wave function, psi, and then in brackets you've got RT. R is simply like a vector which is determining the position of your 3 coordinates of x, y, and z. So you can take that and factorize it into a space part and a time part, and then you can express it in this way. Psi RT, this again on the handout, equals psi r, and then you get an exponential function minus I 2 pi et divided by h. Okay, now the simple point I want to make about this wave function here is that it's deterministic. Very interesting, isn't it? Deterministic. Why then do people always talk about indeterminacy in quantum physics? And the reason is quite simple. We do not observe wave functions. Rather, we observe events. And I'm going to relate this to our forming representations. And a good example of this is radioactive decay, where the nuclei decay and give off these particles, alpha particles, beta particles, gamma rays. And I'll go on to that, say something about that more in a moment. But why is the wave function psi, why can that be deterministic, but events are not? Well, the wave function of a system can be described as a superposition of other wave functions. And so again, you've got this on the handout, you've got psi, which is a superposition of other wave functions. So A1 psi 1 plus A2 psi 2 and so on. And then you've also got various other equations like H psi 1 equals E1 psi 1 and so on. So I'm not going to go through all those, but you've got those on the handout. And when you have this superposition of wave functions, just imagine it's rather like a violin string vibrating, or it's like a singer. So obviously when you get a singer like Bryn Terfel with a very rich voice, one reason it's such a fantastic voice is that you just got the right superpositions. And so imagine therefore that you've got this wave function, capital psi, which is a superposition of other wave functions. Now, according to a standard view of quantum theory, this wave function, capital psi, collapses to one of these what called eigenfunctions psi n, so either psi 1 or psi 2 or whatever, when a measurement is made. And the probability of getting a certain setting is obtained by squaring the amplitude. So take your A1 or whatever and simply square it. Now, it was John von Neumann who applied quantum formalism to measurement in his 1932 work, Mathematical Foundations of Quantum Mechanics. And if a system is prepared in state 1, so if you prepare your violin string as G, bottom G, and you measure it, well, you simply register that. But then if you have a more complicated wave and you have this superposition of waves, you make a measurement, this is actually when the problem starts. And the best way of illustrating this problem is to look at a famous thought experiment of Erwin Schrödinger called Schrödinger's cat, which many of you have probably heard about. So in this cat, I'm going to give you the original version, Schrödinger's original version. A cat is shut up in a steel chamber together with a Geiger tube, in which is placed a tiny mass of radioactive substance, quote, so little that in the course of an hour, perhaps one atom of it disintegrates, but also with equal probability, not even one, end of quote. If it does disintegrate, then the counter responds, and through a relay, activates a hammer that shatters a little flask of prussic acid, and then this kills the cat. Now, the problem with this thought experiment, the problem this thought experiment is supposed to highlight is as follows. Before the measurement, before an observation is made as to whether the cat is dead or alive, the atomic system can be expressed as this superposition. You've got this on the handout. Capital psi equals psi A plus psi B, where psi A corresponds to the nuclei not having decayed, psi B corresponds to the nuclei having decayed. But this superposition on the atomic level must correspond to a superposition on the macroscopic level. So we have a hybrid cat. So psi equals psi live plus psi dead. Now Schrödinger writes that the wave function, quotes, of the entire system would express this situation by having the living and the dead cat mixed or smeared out, pardon the expression he writes, in equal parts. So you've got this hybrid cat. The observer then comes in, looks into the chamber, and it appears that that then collapses the wave function. Now, with due respect to Schrödinger, and by the way, Schrödinger was in enthusiastic Schopenhauerian. Very interesting, this. With due respect to Schrödinger, I'm not really sure that this version of the thought experiment is the most helpful. And one problem with it is that the cat itself is an observer, and the cat can form representations. So the cat will not directly observe the radioactive decay in the nucleus, but it will certainly see the hammer fall, will see the flask break, will smell the prussic acid, and will sense the poisoning process. So I suggest a different thought experiment, and I hope this will appeal to all cat lovers. Keep everything in the thought experiment the same, just don't put the cat in the chamber. And I realise that this lessens the drama of the original version, but it takes out the complication of having a cat there which can form representations. And so in the following, we just ask whether the hammer is up or down. So taking the system of the radioactive source, we have this, and the formula again on your handout, psi equals psi nucleus not decayed plus psi nucleus decayed. And then on the next line, this is expressed using what are called Dirac brackets. So it's a rather elegant way of expressing this. So again, you've got the same thing, psi nucleus not decayed plus nucleus decayed. What we do now, let's take into account something wider, and we're going to think about a wave function for not just the Geiger tubes, not just think on the atomic level, but to include the hammer. So psi equals nucleus not decayed times hammer up plus nucleus decayed hammer down. So now we have this strange superposition on the macroscopic level. We appear to have a ghost hammer, a superposition of hammer positions. But this system of the Geiger tube and hammer is not really isolated, because that then in turn interacts with the environment. And so we could go to this state of ghostly superposition again in your handout. So you've got psi equals nucleus not decayed, hammer up, environment corresponding to hammer up, plus nucleus decayed, hammer down, environment corresponding to hammer down. Now, my bold claim is this. Without a conscious observer, we would have a wave function for the world which would amount to this sort of superposition. So take the world and remove from it all conscious observers, or using Kant's terms, remove all subjects, and we have a strange world of ghostly superpositions, not only on the microscopic level, but also at the macroscopic level. But if we introduce a subject, a conscious observer, the wave function appears to collapse. Such a subject does not have to be a human being. It could be a cat, it could be a bat, it could be an insect. But the subject somehow causes the wave function to collapse, such that we see the hammer either up or down, but not both. This superposition of wave functions reminds one of the noumenal world, a world which cannot be accessed by limited human beings. If anyone can perceive this, it must be God himself. And the world of the collapsed wave function corresponds to the phenomenal world, a world which is created by human and animal subjects. Now, in case you're feeling this lecture is becoming rather like science fiction, I now want to make this a little bit more concrete and ask you what you are observing in this lecture hall. According to Kant and Schopenhauer, each of us is producing a representation. We are, according to Kant, viewing this room through a matrix of categories. Further, you're encountering it from a particular spatial position, a particular time. According to quantum theory, you are constantly measuring everything. So light is being scattered from the carpet, from the walls, from the chairs. In a sense, you are constantly collapsing the wave function, and we have a process which has come to be known as decoherence. My thesis is that ultimately it is the conscious observer who brings about this decoherence. And my approach is therefore rather similar to that of Eugene Wigner's, that it is the conscious observer who collapses the wave function. But such a view has not gone unchallenged, and let us look briefly at three objections to this view that human consciousness is fundamental to the collapse of the wave function. The first, in laboratory experiments, measurements are often carried out by a computer, not by a conscious observer. A second objection is that this approach seems to be demand that decoherence on the molecular level, some molecules in my body taking a particular shape, can only occur when I am in some sense observing them. And a third objection is this: what is the state of the world going to be like before the emergence of animal and human subjects, which is supposed to be related to this, what we call decoherence? These seem formidable objections, but I think they can be answered if we recognise that the measurement by the subject does not have to be by direct means, but can be by indirect means. So let's take the case of measurements performed at CERN. The computer apparatus has been designed by human subjects, and whatever the measuring apparatus produces as output, this has to be examined at some point by a human subject. And so in a sense, you could say that this complex equipment is an extension of the human subject. Taking the case of molecules in my body, it may be that I do not have to observe them for them to have shape. They still have a distinct shape when I'm sleeping, for example. I hope they do. But nevertheless, they only have this shape because they interact with the environment through decoherence. And we only have this sort of environment because of subjects in the world. So the environment, via the subject, continuously observes the spatial structure of large molecules in our bodies. Having this distinct shape results from interaction with the natural environment. And use takes as an example from visual observation. This is on your handout. When we look at objects, we see their form because scattered light contains the necessary information. Left alone, molecules and larger objects would not have a shape. And I think you need to read his article. You need to see that in the context of his article, I think. Okay, the third objection. What is the state of the world like before the emergence of human and animal subjects? Well, this can be answered by saying there is such a thing as retroactive causation. John Wheeler was a great proponent of this, and he writes this. I think this is on the handout. The quantum principle shows that there is a sense in which the observer, so what the observer will do in the future, it defines what happens in the past, even in a past so remote that life did not then exist, and shows even more that observership is a prerequisite for any useful version of reality. And he likewise suggests that the observer is as essential to the creation of the universe as the universe is to the creation of the observer. And if we bring in Arthur Schopenhauer, we realize that this observer does not have to be a human being. Indeed, animals were forming representations long before human beings. And he writes this: You might find this rather shocking, but I think it's wonderful. He says the existence of this whole world, and he's talking here about the phenomenal world, the existence of this whole world remains forever dependent on that first eye that opened, were it even that of an insect. And often we have to think very, very carefully, but I think it's a very provocative statement, which I think is pointing to something which may possibly be true. So, in our everyday experience, we are creating a world of phenomena, a world of representation. Reduce right the properties of the ordinary objects of our experience, precisely those that we call macroscopic, are now seen not to be inherent in these objects, rather they emerge from or are created by irreversible interactions with the environment. And what use is saying about the environment, I would like to extend to mind. Briefly, some theological conclusions. If what I've been saying is correct, then there are, I think, some important conclusions relevant to theology. The first is the limitation of the human mind. We encounter things in the world such that we normally perceive just the phenomena. Our understanding of the world is limited by spatial and temporal categories we employ, and by those wonderful but clumsy categories of language. And Schopenhauer is most insistent on this, that language is such a clumsy tool to use. That's why you have to know more than one language, he said. So we can look at the problem from different perspectives. And so in view of these limitations, no wonder we are unable to encounter things as they are in themselves. Secondly, despite their limitations, human beings together with animals create the world of representation. And the mystery of the mind, I think, finds a correlate in the mystery of the physical world. Thirdly, we are therefore co-creators with God. You could say this: God may create the noumena, but we create the phenomena. And the insights of transcendental idealism, far from being destroyed by scientific advances, have in many respects been confirmed. And so it just remains for me to wish you all a very happy afternoon as you continue to make representations of this remarkable world in which we live. Thank you.
Thank you very much indeed for that. I'm sure that stimulated plenty of questions, so it's over to you for questions and discussion. Please.
As you know, there's a thing called the quantum Zeno effect, which to some extent has been verified, that if you continually observe a decaying object, that can inhibit its decay. Now, why don't we expand this and talk about the cat, in a living cat in Schrödinger's box?
Yeah.
Give it an odourless gas and hide all the mechanism. It just suddenly dies or does not die. But by your argument, it can never observe that it has died, so it must continually stay alive.
You can never observe that it has died. No, it does precisely observe that it dies. Because it anticipates this by, as I say, seeing the hammer fall, the flask break.
It doesn't know anything until it's clobbered.
Yes, but it anticipates this.
It's a pretty dim cat.
Yeah, it's quite a clever cat, I think.
Mine is a stupid cat.
It's all right.
Okay, that's a point that can be picked up in discussion afterwards, I think, as well. So, please, yes. Yeah.
So,
yes, please. Yes.
So I'm wondering why, even if the cat is conscious, why we can't, suppose that it is a superposition of two different states. Or maybe I misunderstand.
So even if it's conscious,
So
yeah.
if I I could have misunderstood what you said, but it seemed like you said that if something is conscious, then that collapses the wave function.
Yeah. I think the point is what I'm trying to say is that the original version of Schrödinger's cat is confusing because you have this cat in this casket, in this steel chamber, which itself is doing the measurements. It's actually forming a representation. And so that's why I wanted to remove the cat, simply to ask whether the hammer was up or whether the hammer was down. And so you're simply thinking then of an observer outside of that steel chamber. You see, so that was my motivation, really wanting to remove the cat from the thought experiment.
Okay, please, yes.
I'm trying to formulate the question.
Yeah,
I think
yeah.
you might be able to help me. You said about Jesus, those to whom Jesus chose to reveal himself. Now,
Yeah.
could you enlarge on that in the light of this? Was he choosing, or were people? Was it people as subject who were seeing?
Yeah, okay, so what, if I just put this in context, then what Schopenhauer argues is that there's always a certain subject-object correlation. In normal, everyday life, as I'm experiencing this room now, it's according to the principle of sufficient reason. And he says, but now and again, the subject and the object go into a special state, and as I understand it, when people see the risen Jesus, the subject is going to a certain state, and that corresponds to a certain object as well. And obviously, it's to do with Christian faith. So this is why I was trying to argue that when you look at 1 Corinthians 15, for example, when he talks about Jesus appearing, the Greek is literally, he lets himself be seen. And so he discloses himself to certain chosen individuals. So in a way, they are the chosen ones. They are chosen by God to receive this resurrection appearance. And then you can apply this also to the experience of art. Yeah? So I went to see Tristan and Isolde in Bayreuth, and in the second act, I felt, like I never felt before. You can apply Schopenhauer to that. The subject was in a certain state, that corresponded to a certain object. And you can apply it in lots of nice ways. And what strikes me is that lots of people actually do work on the human person, do not seem to take into account all this stuff we've got in the New Testament where demons are cast out, people have visions, see them as Jesus and so on. And a lot of work I find on human anthropology is terribly two-dimensional.
Please, yes. Yes, please. Yeah.
So, in what sense do you understand God creates?
I suppose I understand God is the one who creates the thing in itself.
Do you understand God as
sorry, yes.
subject?
Sorry?
Do you understand God as the ultimate subject? Is that what you mean?
You could view him as the ultimate subject, yeah. And the ultimate subject the only one who can encounter things as they are in themselves.
And that's the distinction between God as a subject
and humans as a yeah. So humans as subjects, because of their spatial, temporal, linguistic limitations, simply form this world of phenomena. If I could just give you an example of this, I mean I haven't brought this in my talk, but what is the human soul? I would not equate that with the human mind in any sense. I would say that's the body in itself. You could look at it in those terms. So God can encounter the human soul, and God sees the soul, whereas we usually see the human body. So the human body you could see as a manifestation of the soul. And so God is this special subject precisely in that he can encounter something without using spatial temporal categories and so on.
Please.
Is that a sort of Thomistic view of the soul that is informed by every part?
Not really. It's got one or two echoes with Thomism, possibly, but it's in a way my own sort of view I've developed really from Arthur Schopenhauer, because Schopenhauer talked about the will as the thing in itself. And what he says about the will often seems to sound a little bit like what Christians talk about the soul, actually. So it's really something that comes out of Kant and Schopenhauer, really, this understanding of the soul. And I developed this partly because all the work I was doing about, if we talk about participating in Christ, how can we understand that? Only through the use of the soul. So the human soul is brought together with the soul of Christ, and thereby we participate in Christ.
So you've detached the soul from the mind.
Yeah, that's right.
And therefore from the brain?
No, well, what I do is, I haven't got a thing to write on, have I? But I talk about, the simplest view of my anthropology, I suppose, is what you could call like a cone of personhood. So the subject of mind is like the tip of a cone. And that goes down into the noumenal world. So there is a link between the mind and the soul. And you could say the mind is something which emerges from the soul. And if you use this is the way in which you could perhaps relate the mind to the brain.
Only perhaps.
Sorry.
Only perhaps. I mean, it's
only perhaps.
You know there's been a great fashion over the last 30, 40 years to call people dead when their brain only has been tested. Would you accept those people as dead?
If the brain is dead.
If the brain really were, I mean, it's very difficult to test it thoroughly and make sure anyway.
Well, I mean,
I
wouldn't want to make any judgment on that, but I would say, but I'd hold though to the eternal soul.
Yes, but where is it? And has it gone?
It's in the noumenal world.
We're not going to get any further.
Well, no, we can get further. We can actually pursue this, because I think this is actually crucial, recovering the soul in Christian theology, and also in the whole debate between theology and science, because the soul has just been, I think, just completely shut out. And I would say you can take a human person, you can torture them, you can kill them, you can throw them into a pit, but the soul is still there, because the soul is something which transcends space and time. So I hold very, very firmly to what we call the immortality of the soul. Not necessarily in the Platonic sense, but I think there's an aspect of the human person which transcends space and time, and I like to call that the soul.
Okay, question over here. Yes.
You say that conscious humans collapse the wave function. I wonder at what scale things stop collapsing the wave function. So a carbon atom wouldn't, but would a virus or a bacteria?
Yeah, this is, I suppose, why I was trying to say that although the human subject may not directly collapse the wave function, it could happen by indirect means. So if I'm just giving an example, if you take the molecules in my body, they have a particular shape because they are interacting with the environment, essentially. And what I'm doing, I'm just doing a big chain and ending it up with a human subject. Okay, so sorry?
Suppose there were no human.
If there are no human subjects, I don't think there'd be any decoherence. No.
But you say that animals.
Oh yeah, but they're also subjects.
Yeah, I know, but how small can subjects go? I mean,
well,
there's a millipede a subject.
Yeah.
And then is a virus, like the
well,
flu virus. Would that be a subject?
Okay, this is a thing I need to apply my mind to. How far do you go down?
Yeah.
Yeah. Okay. Because I mean, Schopenhauer gives the example of an insect. I think you'd have to say that a subject must be anything which has some any sentient being.
Well, that seems very woolly.
It's very, very woolly. It's very, very woolly, and this is something which needs further work on. I do not dispute that. I do not dispute that.
Peace, yes. You could say in that context that the observer can be something as sophisticated and complex as you like, because the only things that make a difference are those things of which the consequences are observed. So if a cat dies as a result of a quantum event in the middle of the jungle and nobody ever hears about it, and the same with a virus or an insect, if we observe the consequences of that insect living or dying, or if, so that it doesn't matter how low down the system, the scheme is, provided it eventually results in an observation by a conscious being.
Yes, okay, but again, you know, the jungle is going to be full of conscious beings as well. So if
if somebody argues how conscious does it have to be,
okay.
It doesn't matter if eventually it gets to something.
Right. Okay. Yeah. No, I see the point.
Okay. There's another one just behind. Yes, were you going to ask a question?
I think we're thinking about similar things, but
Yes.
maybe, and I don't really know the answer to this question, but it seems like there are different wave functions for different observers, right? So if I observe something, then I've collapsed it to some sort of wave function for me, but somebody else who might want to come and see what happens later, to them it's still, it could be in the state where I observed it, I observed the cat alive, or it could be in the state where I observed the cat being dead. So the wave function isn't collapsed for them.
Yeah. Okay. I mean, I suppose the only complication is what you do then at CERN when you have, you know, a computer doing the measurements for you. And I guess there has to be surely some agreement between human beings as to like the representation you're forming.
Can I?
Yeah, sure.
Yes. Question, because the point you're asking depends on. So you know, there's this thing about the propagation of this wave function back to the original silicon state. So that means that actually once the wave function is being collapsed, then when the measurement is made, there's a time where it stays in an eigenstate, but then it actually, because due to the evolution of the unitarity of the Schrödinger equation, it actually propagates back to the full wave function and back to the situation. So what you are really asking is, how do you define the state of time within which you call that the collapsed wave function that you collapse? And that question is very difficult because it involves relativity, it involves whether you're transferring information faster than the speed of light and all that. So that has a more technical question, because I think it is defined technically, mathematically, it is one. How long it takes to get there as well.
Okay. Do you want to comment on that, Richard?
No, that's fine.
That's fine. I think we probably should. We do promise people we finish up on 2 because we know people have lots of other things to do. Our speaker today has greatly stretched our minds and our thoughts, and I think we should thank him very much indeed for that. So thank you.